Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to begin talking about curves in SOLIDWORKS. Now, we've already done a video on inserting blueprints into a SOLIDWORKS design, so if you need help with that, make sure that you do check out the video that we have on the screen now. What we're going to be doing is we're going to be adding a blueprint image that comes from this drawingdatabase.com. You can go to the link in the description. This is a website that claims that all these are royalty free. You can use them for whatever you want. So I like to go to this website as sort of a first stop when looking for blueprints. You can obviously download whichever blueprint you want. We're not going to be modeling the car. We're only going to be looking at building 3D curves. If you want to follow along with me, then make sure that you go to the second page and you look for the Honda S2000. So it'll be a little bit going on the screen because there are a lot of ads, and it's kind of how these websites work when they provide free content. They all have a lot of ads on them. But once you get there, you can see that there is a blueprint image of this S2000. Full disclosure here, this is not quite to scale. So if you look at this, you can see that the height of the front view is a little bit lower than the height of the side view, and the scale of the top view is actually a little bit off as well. Again, because we're not modeling the car, that's not a huge deal, but when you go ahead and insert this into a SOLIDWORKS design, then you want to just make sure that you understand that these scales are probably a little bit off. Back in SOLIDWORKS, I'm only going to be using the side and the top view, so you don't even really need to worry about the front view and the fact that the scale is pretty far off. The top view will need to be scaled up, and generally what I do is I try to make sure that both of the blueprint images are transparent, at least 50 or 60%. And because the S2000 actually had vertical lines around the outside of the car, it's very easy for us to scale up that top view until it pretty much meets that size, that vertical line there that's going to the dimensions. So make sure that you do have some reference image, whether it's this S2000 or anything else. Make sure that you do have that inside of a SOLIDWORKS scene, and then we can get started talking about curves. A couple of other things that I'm going to do inside of my user preferences under colors, I am going to change the color of my projected curves. Now, in this case, if we go down and we take a look at, I have to scroll down quite a bit for this, construction geometry, this is actually what the projected curves end up being, their construction geometry. So I'm going to give it a brighter color, like a pink, maybe make it a little easier to see. And I'm also going to go to the classic icon colors. I am not a big fan of the blue and gray colors that have come out in SOLIDWORKS since, I don't know, 2016 or so. So I always like to go back to the yellow colors, the sort of the old classic colors. So if yours look a little bit different, the tools are still the same. They'll still have the same name and still work. But I just like to go back to this color scheme. With all that out of the way, let's go ahead and talk about the two things that we're going to cover in this video. The first thing we're going to cover is projected curves. Now, projected curves are probably the most common way that I model cars or complex objects, but we can also do those with 3D sketches. So we're going to cover both methods so you give an idea of how both of them work. To do the projected curve style, we're going to start with a side view. So find the right plane. We're going to create a sketch. And the curve that we're going to be doing here is going to be this sort of major body line. It goes from the front wheel arch all the way to the tail light. We're going to do this with a spline, but we're going to be using what's called a style spline. Now, in general, the style spline is going to give a much nicer result, and it's going to give us a bit easier time in actually controlling that geometry. If you want to use the traditional spline type where the points are actually on the spline, you certainly can. It's just going to be a bit harder to get a nice smooth curve out of it. We're going to leave it as a Bezier curve. You can go to 3, 5, and 7 degrees if you want. And this really just comes down to the number of points that are required to make that curve. So I'm going to leave it as Bezier, which is sort of open-ended. We can also change those at any point in time if we need to. We're going to start by clicking here. And I'm going to click somewhere in the door because this is not a straight line. It does have a little bit of curvature. And if you find it snapping, hold down the control key. That'll temporarily override those persistent constraints. And once we get to the end, hit escape to end the spline. Now, everything that we've done here is going to be pretty easy for us to replicate with a traditional spline. But what I want to do is show curvature. I'm going to increase the scale. And one thing that you'll note here is that as we get closer to the end of that spline, the curvature ramps up. And that's fine because it's mostly straight between these first 2 points. And then the second point, if we zoom in, we can kind of see what we're working with here. And then that third and fourth point there, you can see that we're getting a big change in that curvature. And that's perfectly fine. That's not a big deal. That's not a problem. But it does allow us to see what the curvature is doing. So the next thing that we're going to do is finish that sketch, and we're going to create a new sketch on the top plane. Now, the first thing I generally do is I'll select the curve, my first curve on the side plane, and I'll convert entities. After I convert entities, I'm going to turn it into construction. And then this is an extra step that I don't generally do, but this is something that helps in videos, is I'm going to draw a horizontal line. I'm going to double click, and I'm going to draw a horizontal line from the front as well, and double click, and then hit escape to get off my line tool. These will also be construction. And the main reason that I do this is because whenever I'm working with projected curves, I'm going to go ahead and rotate this down. Holding Alt and the arrow keys will allow you to rotate the view. I just like to view it this way because of the widescreen. So anytime you are creating a projected reference, it's extremely helpful to know that the second curve, in our case the top-down curve, is going to align to the endpoints of the first curve. So generally when I'm modeling something like this, and I'll show you a quick example, if I'm modeling something like this, what I will do is I'll take those endpoints and I'll make them vertical or horizontal in relation to each other, depending on the orientation of the sketch. So in this case, I wouldn't need to have those construction lines to help me view where it's hitting the car body. But as I said, in videos, because these are always hard to see anyways, it's a bit easier to have those reference lines. And if you need to add dimensions to them, you can. So next, we're going to create another style spline. This time we're going to have to zoom in and pan while we're doing it. But we're going to start here, and we're going to start to work our way back because this sort of comes in and then it works its way back out. Now to pan, I'm going to hold down Control in the middle mouse button. Because I work between a bunch of different CAD softwares, it's oftentimes easy to forget which button does which. And then I'm going to snap it here and hit escape. I'm going to bring that endpoint there. Now you can see that with the style spline, these points that I clicked on are not actually where the curve is. So you may need to do some adjustment after you've placed these points, which is perfectly fine. Just go ahead, grab them and move them around. But then make sure that you do show the curvature and get a good idea as to what that curvature looks like. Now you can increase the scale and the density if you need to, but really what we're looking at is we have curvature going in one direction here, and then it crosses and goes in the other direction, and it stays on this side of our curve. That's important because if the curvature cones have another inflection point in the middle of the car, that generally means that we did something wrong. Because the way that this car, the shape is and the curve is we shouldn't have another inflection point going from convex to concave. But now that we have that curve, I'm going to go ahead and finish my sketch. I'm going to hide the side and the top profiles here just to make sure we don't need to see them. And basically what we're going to be doing is taking this out and taking this one up. As an example of this, I'm going to go ahead and do an extruded surface. Again, not required here, but in this case, it's going to be easier for us to see what's going on. So anytime we're creating a projected curve, basically what we're doing is we're extruding that curve out normal to whatever sketch plane it was created on. And where it hits another curve is going to be our result, our intersection. So I'm going to expand these two surfaces. I'm going to bring back those sketches. And then I'm going to go to my curves menu and create a project curve. Project curve, again, we'll select the same things. And you can see the yellow preview line, which is going to turn purple or pink because I changed the default color of it. Yours will still be a blue color if you didn't change it. That lies exactly where the two surfaces intersect. Now, it doesn't really matter if you're using different sketch planes. If your planes are at an angle, it's still going to go out normal to wherever your sketch is. And that's going to give us that resulting intersection. So if I hide those surfaces, what we're left with is that curve. Now, if I bring back my side and I bring back the top, what we should be able to see, I'm going to use Control and Space to bring up this little cube thing. What we should be able to see is that those sketches, that purple line is going to fall exactly where we placed it from our side view. And from the top view, we should get the exact same thing. It follows exactly where we had placed it. And now we have that method where we can create those projected curves. Now, a couple of tips for you. If you are going to carry on building more curves off of this, then you do want to make sure you still use that convert entities and you make sure that the endpoints are in the same location. I would say that if you're having more than one change in curvature direction, to break it up into multiple curves. So in this case, from the top down, we had that inflection point going inward, and then it kind of changed. So it went from convex to concave. I think that's perfectly fine. If it were to change directions again, then normally what I would do is break that into two separate curves and ultimately create two separate surfaces from it. With that said, let's look at the exact same process of how we would do this with a 3D sketch. Now, I generally avoid 3D sketches whenever possible because they're harder to control, but there are some benefits. We do have the benefit of the fact that a 3D sketch has fewer inputs. When we create a projected curve, we need two 2D sketches, and then we need the curve feature. If we're doing a 3D sketch, we can theoretically draw all the curves in one sketch. It would be a nightmare, but you could do it. So when we're doing a 3D sketch, oftentimes it's best to pick a direction, just like we would with projected curves, and then move in the other direction. So we're working in 2D, and then we're going to move in our third coordinate system, our third axis. I'm going to, again, use the same type of spline, a style spline. And because I'm looking top down, it's going to default to automatically creating a 2D curve for me. And because I haven't selected any points in 3D space, this is going to happen on the default plane. So we're going to come here. And we want to do this with the fewest number of points possible. And that's really because once we get into moving curves in 3D, those are going to be much harder to control. So once we're looking at it top down, I can grab these points, I can pull them around. And once I'm happy with that, if I rotate this around, you'll see it's on that top plane. So I'm going to select the entire thing. I'm going to go to a side view. And I'm going to use move entities to move the entire thing up until my first point is in the right location. From here, again, it's going to get a little tricky, but what we want to do is move each of these points up to their correct reference. Now you can do this manually by grabbing these points. You can grab them in a group, but when we're using a style spline, remember that the cage itself is not going to lie on the spline. What this means is that you're generally going to have to make some modifications because the surrounding curves are going to affect the overall location. So if you want to, say, bring this spline up to the correct location and then rotate it before you make these final minor adjustments, that's perfectly fine. There's nothing wrong with doing that. This can be a tricky process. And again, the main reason that we want to highlight this is to show the difference between doing this as 2D projected curves and doing it in 3D. So if I take a look at this and I try to show curvature, now the curvature here is going to be a little bit tricky because what we're dealing with is a curve in 3D. So if we highlight this, it'll show those as orange when our cursor's over it and then blue. But if we rotate this around, we can see that we're getting curve inward and outward from the top. This is what we would expect. And then from the side, we're also seeing that curvature going up slightly, and then it's going down slightly in the back. And what this means is that those points are not in line with each other, which again, depending on what you're modeling, doesn't necessarily mean a bad thing, but it is something that we need to be aware of, especially as we manipulate this around and we watch these curvature combs. We've got these points going up and then this one coming down. That's generally going to be a bad thing. That's something that we want to avoid. We want them to all be fairly gradual. So from the side, I don't really want to see these curvature combs, and it would take a little bit of work to be able to do this, to get it so that those curvature combs are either non-existent or fairly minimal. So that's the basic process of doing this as a 2D projected curve and doing it as 3D curves. Now let's go ahead and let's bring back our projected curve and take a look at the differences between them. So they're not perfect. They are relatively close. If I look at it from the side, and I know that this is hard to see because one of them's pink and one of them's gray, so I'm just going to zoom in. We can see that our pink curve is below and the 3D curve is above, which again, they're pretty close. So for modeling this car, it wouldn't matter. But we can just kind of follow it along and we can see what happens. The pink one stays somewhat consistently above, and then it crosses below here and it finishes at a different point. I'm going to go ahead and go to a top view. And again, same story. The pink one is a little bit inside the 3D curve. Again, not a huge deal, but they are different. So they are in different locations using the same reference images. In my opinion, it's a little bit easier to do these as 2D projected curves. So what does all this mean? Well, the reason that we're doing this video is because we're going to be covering some surfacing type videos and content on this channel. So we want to make sure that we at least have a foundation of creating projected curves using 2D and also generating 3D sketches and building those splines in 3D. With those two basic workflows out of the way, we should be able to progress into creating these 3D complex surfaces that we're going to be getting into. Now, if you are brand new to SOLIDWORKS, brand new to trying to model complex surfaces, I do suggest that you spend a little bit of time working on basic sketching and basic modeling before you try to attempt to do complex surfacing. A lot of those basic tools, things like generating sketches and doing basic sketching tools like trimming and extending and just using lines and arcs, those are things that we're not going to dive real deep into. We're going to focus more on the surfacing tools. So make sure that you do have a foundation there. Make sure that you are comfortable with everything we did in this video, especially the 2D projected curves, because that is the main approach that I generally take when modeling. If you have any questions on this, please leave a comment below. As always, thanks for watching, and we'll see you in the next one.